Good day, viewers at home. I remain Engineer William plus S. In our today's class, we shall be discussing capacitor and capacitance. What is a capacitor? A capacitor is a device that is used to store electric charge. And capacitance is the ability of a capacitor to store such charge. And that thing you need to know is that a capacitor is made up of two parallel plates. A capacitor is made up of two parallel plates. So these plates are metallic. Then in between the plates, there is an insulator. So there is an insulator that separates the plates of a capacitor. And this insulator is also known as dielectric. So that is a capacitor. The symbol of capacitor is just this. This is the symbol to represent a capacitor. It is different from that of a battery. That of battery is not of equal length. So what are the factors that can affect the capacitance of a capacitor? What do I mean? What are those things that will make a capacitor to store less charge or to store more charge? One is distance between plates. The distance between these plates can affect the charge it can store. Number two is the area of the plate. Area, that is the thickness of the plate, can also affect the capacitance. How does distance affect the capacitance? So you can say that capacitance is inversely proportional to distance. What does that mean? The more the capacitance, the lesser the distance between the plates, and vice versa. You can call this equation 1. Then capacitance is directly proportional to area of the plates. You can call this equation 2. What does that mean? The more the area, the thicker the plate, the more the charge it can store. So if I combine these two equations, we have C is proportional to A times 1 over D. So that this times this will give us C proportional to A over D. So if I remove equality sign, the proportionality sign, and introduce a constant, we are going to have C is equal to EOA over D. Then this EO is known as dielectric constant. Dielectric constant. Or you can call it a permittivity. Permittivity of the free space there. So if I look for the value of this, I'm going to have this multiply this, that is if I cross multiply, I have CD should be equal to EOA. Then if I make the substitute formula, I'll have EO equal to CD over A. So that the unit of C is farad, that is capacitance. D is meter, and area is meter square. So if you divide this with this, we now have that EO will be equal to Fm raised to power minus 1. And the value of this particular constant is equal to 9, approximately 9.0 times 10 raised to power minus 12 F raised to power this. That is the unit for this, the value for the constant, which is known as permittivity dielectric constant. So the value of the constant is 9.0 times 10 raised to power minus 12 farad per meter. So that is a capacitance. And that thing we know is that capacitance is the ratio of quantity of charge over potential difference, or you can say voltage. So the ratio of quantity of charge to potential difference will give us capacitance. So you can say that capacitance is equal to Q over V. Quantity of charge is measured in coulomb, and potential difference is measured in volt. You already know the unit for capacitance, which is farad. So this is another formula for calculating capacitance. So you use this when you have quantity of charge and voltage. But the other formula I gave to you here, you only use this when there is dielectric constant area and distance between plates to calculate the capacitance of the capacitor. I hope that is clear. The next thing we look at is arrangement of a capacitor. Arrangement. How do we arrange a capacitor? We have two major ways of arranging a capacitor. The first is series arrangement. If you arrange the capacitors in series, it looks like this. You can call it capacitor 1, capacitor 2, capacitor 3. I would have go straight to prove this, but because of I want the video to be short, I will just summarize it. So whenever capacitors are arranged end to end, you say the capacitor is arranged in series. One thing you should know here, or the things you should note here, is that whenever capacitors are arranged in series and connected to a source of voltage, the voltage, the voltage in this capacitor, the quantity of charge in this capacitor remains the same thing. The quantity of charge here is the same thing as the quantity of charge here, and the same thing as the quantity of charge here. But the voltage will now differ, so that if you want to get the total voltage, we are going to have V1 plus V2 plus V3. That is the voltage in C1 plus the voltage in C2 plus the voltage in C3. So the capacitance will now be 1 over C1, sorry, CT, that is the total capacitance, will be equal to 1 over C1 plus 1 over C2 plus 1 over C3. So this is the formula for calculating capacitors in series. So whenever your capacitor is arranged in series, use this formula to find the capacitance. That is that. Then this formula can still be summarized. If you are having just two capacitors in series, and you don't want to look for the LCM, like this requires LCM, you can just say 1 over CT is equal to 1 over C1 plus 1 over C2. What is the LCM of C1 and C2? The LCM of C1 and C2 is C1, C2. So that C1 go here will give us C2 plus, and C2 go here will give us C1. C1 times 1 will give us C1. So this will now be equal to C1, C2 divided by C1 plus C2. So you can just use this to find the capacitance of a capacitor if it is arranged in series. Just two capacitors arranged in series, just the product over the sum will give you the total capacitance. Then the another way you can arrange capacitors is parallel. So if capacitors are arranged in parallel, it looks just like this. So this is parallel arranging the capacitor. And when capacitors are arranged parallel, the voltage in the parallel combination is the same thing, or the potential difference. Remember, for series the voltage differ, but here the voltage in C1 is the same as the voltage in C2 and is the same as voltage in C3. But for series it is not the same thing. So if you want to get it, but what changes here is that the quantity of charge will no longer be the same thing. So the quantity of charge in C1 will differ from the quantity of charge in C2, and the quantity of charge in C2 will differ from the quantity of charge in C3, but the voltage is the same thing. So that the total capacitance, which is total, will be equal to C1 plus C2 plus C3, and so on and so forth. So this is formula for finding capacitors in series. Let's just go straight and look at some examples on this capacitor. Let's look at this question here. The question says the total capacitance of the circuit below is, we have to look for the total capacitance here. So what do? Before you solve a question like this, first of all analyze and see the one that is series and the one that is parallel. If you look at this particular question, these 1, 2, 3 are parallel to each other. So what do? I first of all calculate the parallel resistance. For parallel, it is just C1 plus C2 plus C3 from what I just explained. So that total capacitance will be 2 plus 2 plus 2, which will give us a total of 6 microfarad. Then if I redraw the diagram, I will have this. So here will be 6 microfarad because the total has given me 6. And here will now be 2 microfarad. Don't mind me, this means microfarad. So this is now in series with this. For the series, I am going to have 1 over Ct is equal to 1 over 2 plus 1 over 6. So that 1 over Ct is equal to, what is the LCM? LCM is 6. 2 go in 6 will give us 3. 3 times 1, 3. Plus 6 go in 6 will be 1. 1 times 1, sorry. 6 go in 6 is 1. 1 times 1 is 1, which will be equal to 1 over Ct is equal to 4 over 6. So that Ct will give us 6 over 4. That is if you interchange, take the inverse, which will be equal to 1.5 microfarad. That is the answer to the question. I believe that is clear. Then let's look at another question on that. Here we're having three 2 microfarad capacitor. So we have three capacitor, but each of them has a capacitance of 2 microfarad. As you can see in the diagram below, we have to look for the effective or the total capacitance. What do? This and this are already parallel. So for the parallel, Ct will give you C1 plus C2, which will be 2 plus 2. And 2 plus 2 will be equal to 4 microfarad. I hope that is clear. If you redraw the diagram, we have, remember, this and this gave me 4 microfarad, and this will now be 2 microfarad. You can see they are now in series. So if they are in series, for you to solve series, you can also use the C equal to product over sum, which is C1, C2 divided by C1 plus C2. So Ct will be equal to, what is my C1? I can say 2 microfarad times, what is my other one? 4 microfarad divided by 2 plus 4. 2 times 4 will be 8, and 2 plus 4 will be 6. So if I divide 8 by 6, I will have 1.33 microfarad. So that is the effective capacitance. I hope that is clear. Next question. The net capacitance in the circuit below is, you can pause the video and see if you can solve this. What do? You look for the parallel first. So for the parallel, we have 2 plus 2, which will give us 2 plus 2, which will equal to 4 microfarad. 4 microfarad. If I redraw the diagram, remember this and this gave me 4 microfarad. So if I redraw the diagram, I will now have that 4 microfarad is now in series with this other 4 microfarad. So I have 4 microfarad here and also 4 microfarad here. This is now in series. So I can now use the series formula, which is Ct equal to product 4 times 4 divided by sum, which is 4 plus 4. What is 4 times 4? 4 times 4 is 16, and 4 plus 4 is 8. 16 divided by 8 will be 2 microfarad. And that is the answer to the question. I hope that is clear. We are going to stop here for today. Thanks for watching. Kindly subscribe.